Using the SPD notations, describe the orbital with the following quantum numbers. N equals to 1, L equals to 0. You need to remember N equals to 1 will remain same, L equals to 0 corresponds to S. So this is
Yes.
the orbital 1s, which you need to write. 1s will be the answer. N equals to 3, L equals to 2 means 3, 2 means D. Write the numbers and corresponding digits 0, 1, 2, 3, 4, S, P, T, F, 2 is D. 3 and L equals to 1, so it will be 3. L equals to 1 means P. 2 P. 1 means P. 4 F. 3 means F. 4 D. 2 means D. So this is how you will be writing the orbitals, orbital notations in this manner. Now the question, list all the values of L and ML for n equals to 2. This is something I want you to solve in the notebook, and you will send the snapshot to me after the class. List all the values of L and ML for n equals to 2. When you get this question in the examination, this much time is sufficient
Yes, sir.
to
Completed.
solve this type of question. Okay. You don't need to
Sir,
tell
do
me
we
the
send it?
answer. Yes.
So do we have to post the answer in the chat box or send a
No, you
screenshot?
don't need to post the answer in chat box.
Okay.
You need to send the answer to me after the class
So through WhatsApp.
through WhatsApp, just a snapshot of those questions only which I am asking.
See.
Okay, fine. Now, before I move further, mark your presence. Just write present in the chat box. Fine. Just I am giving you a hint so that you can do all those similar questions. I'll solve later on. You have to write all the values. So if n is 2, find what values L can have. Then for each value of L, what will be the value of ML? For example, -1 to +1, -2 to +2, or -3 to +3, or only 0. That's what you have to write here. Next question. How many orbitals of all kinds are possible for n equals to 3? You need to respond in chat window. In chat, you need to respond how many orbitals of all kinds are possible for n equals to 3. Faizan, Tanu, correct. Ariman, think again. Vicious, Laksh, think again. Atman, correct. Samad, think again. Amir, correct. Karthik, correct. Pratham,
Sir, I have
Prateek,
written all the values.
Manuel, okay, correct.
Sir, have I written correct?
I'm just going through the chat window.
Sir,
Arjun,
actually,
read the question. Arjun, read the question again. Sabya, yes. Devyansh, although correct, read the question again. Vedant, Arnav, yes. Arna, Sanskriti, Gyanendra, yes. Ayush, no. Ayan, yes. Samad, although you have written a few, okay, but read the question again. What is asked in the question? Ariman, no. Kshitij, yes. Shivani, yes. Arjun, yes, that is the answer now. Tanishi, Devyansh, yes, now. So you just need to apply the formula. How many means number is asked, not the orbitals. So the answer will be just n square. Number of orbitals in a shell n square of all kinds, S, P, D, F, whatever, means 3 square equals to 9.
So do we have to send this up?
No,
Do you?
not this one. No. Next, if the quantum number L has value of 2, what are the permitted values of the quantum number MS? You need to respond in chat window. Question cannot be easier than this one. So easy. Arman, read the question. Savve, Amir, Yash, Vedant, Kartike, Pratham, Arjun, all except Arjun, all think again. Arjun correct. Faizan correct. Tanu, Kavish correct. Samad, read the question. Kartike, read the question. Atman, yes, correct. Tanishi, it is what are the permitted values, not the count. What are those permitted values? Question is so easy. Atman, yes. Pratyush, no. Laksh, yes. Arna, no. Tanishi, no. Ayan, no. Devyansh, yes. Okay. MS. MS is spin quantum number. Why are you telling me the ML? Why are you telling me magnetic quantum number? 80% students are telling me magnetic quantum number. Quantum number MS is asked. Might be you are on mobile device and this MS is looking as ML probably. MS can have only two values, half and minus half. That is the answer. Whatever shell, whatever subshell, whatever orbital, it will have these two values only. This does not matter here. L has value 2, does not matter. Any orbital will have plus half and minus half value. Okay, so what I'm getting, you need to read the question carefully. Many students are not just seeing what is asked. Next, how many electrons in a given atom can have the following quantum numbers? These type of questions are slightly tricky. Okay, slightly tricky. How many means you have to find the number of electrons which can have this configuration. Okay, Yash Goyal, no. Okay, first tell me in the chat window. Just let me see how many of you can give answer. Ariman, yes. Samad, read the question again. What is asked? Tanu, think again. Arjun, Kavish, correct. In such questions, there will hardly be answer in odd numbers. I'll tell you when the answer can be in odd numbers, okay? Otherwise,
Sir,
no.
can you please check my answer once?
Um, okay. Pratham, Yash, correct. Kartike, check again. Tanu, check again. I am explaining it again. For n equals to 3, okay, for n equals to 3, L can be 0, 1, and 2. Three values possible of L, starting from 0 to n minus 1, 0, 1, 2. But it is given only 1. So you have to consider for 3, L equals to 1 only. And if it is subshell is 1, for this ML can be minus 1, 0, plus 1. These three orbitals can have 6 electrons. Each orbital will have 2 electrons clockwise, anti-clockwise, clockwise, anti-clockwise. So 6 electrons they can have.
Sir,
Yes.
sir, how do we got 6 electrons?
Okay. First, were you able to understand how I got the subshell? Subshell is given 1 only.
Yes, sir, got.
This one. So we will not consider this one. We will not consider this one. In question, it is given for shell 3. I am considering only this subshell. It is given. But this subshell will have 3 orbitals because orbitals will be minus L2 plus L. So it is
Yes,
1.
sir.
It will be minus 1, 2 plus 1. So if there are 3 orbitals and one orbital has how many electrons? One orbital can have how many electrons?
2.
2. So in 3 orbitals, there will be 6 electrons. That is the answer.
Okay, sir. So, sir, we have to do this in the notebook.
Same logic.
So can you solve the previous questions? I got disconnected.
The previous question was simple. MS can be
Yes,
only plus half and minus half. Okay.
yes, sir. Understood. So I thought of MN.
Now, on similar points, tell me the answer of this one. How many electrons this configuration can have? Answer is very easy. Subway, correct. Samarth, yes, you need to think again. Ariman, no. Arjun, yes. Tanu, yes. Divyansh, yes. Samarth, think again. No, Samarth, correct now. Amir, right. Amir, correct. Shivani, Arna, Kavish, Lemuel, correct. Okay. I might have missed a few names because it is scrolled very fast. It is correct because third shell will have 0, 1, 2 subshell. So we are considering only two. So of third shell, second subshell will have five orbitals, -2, -1, 0, +1, +2. But we are considering only 0, so we will consider only this one. M is 0. N, L, Ml. Ml is just 0. This 0 will have only 2 electrons. One orbital can have only 2 electrons. So answer is 2 electrons.
Sir, can the question be presented in a way that for ml instead of 0 we are given two separate values? So then we'll have to write the total number of electrons.
Yes.
Like according to the count.
It will be just, I'll have similar question. Okay. You don't need to write 2. Rather, you need to omit value of L, for example. I'll show you
Yes.
how. This one, how many electrons?
The third part or second part?
Third part. So second part we have already done.
Okay.
Subject Kavish, correct answer. Tanu, think again. Arjun, correct. Pratyush, yes. Fazan, Amir, correct. So till here, basically, it is similar to the previous question. Till here. Third shell. In third shell, we are considering only second one, not 0 and 1. Only second one. Within this one, there can be 5 orbitals, -1, -2, -1, 0, +1, +2. But we are considering only +2. And this +2, here it is mentioned, it has only ms plus half, not the minus half. So if it is just plus half, it means one electron we are considering, we are not considering minus half. So there will be only one electron which will have ms plus half. So understand it up to here. Up to here you got there will be only one orbital. Similar to this one. This one orbital can have 2 electrons. This can have 2 electrons. But it is restricted from here. We will not consider the half, minus half. We will consider only plus half, means one electron only.
So if they were both, then we will have to consider this one, two electrons.
If it is both, this will not be written. If both electrons are
If either
considered.
one is written, then we will consider one electron.
Where one is written? Here, are you saying
So
here
half.
one is written?
Yes, sir. Yes.
No, here never one will be written because the notation is that plus half represents clockwise and minus half anti-clockwise. One will never be written.
So if minus half is written,
Then the answer is same. We are not considering the clockwise. We are considering only anti-clockwise. Then also there is one only. Just understand, if there is just one orbital, within one orbital, one electron will be clockwise, another one will be anti-clockwise. There will be 2 electrons in one orbital, but one will have plus half and one will have minus half spin. So this is the way to denote clockwise, anti-clockwise spins. If it is written minus half, it means this one is not being considered. Only one is being considered.
Sir, is this situation practically possible, sir, that there is only one electron, either clockwise or anti-clockwise?
Yes, it is.
Okay.
Now this one is very easy because you know the formula, how many electrons in here. Arjun, correct. Faizan, think again. Amir, think again. Atman, correct. Pranav, correct. Lemuel, think again. Sabhi, correct. Kartikeya, correct. Pratyush, correct. Samad, think again. Samad, I think you love the number 7. 7 is hardly any answer here. 7 will hardly be any answer here. Pranav, yes.
So I thought you to
Mike,
calculate it separately. That is why.
correct. Okay, number of electrons, you know number of orbitals. Number of orbitals
9.
will be n square. Number of electrons will be twice of n square. That is twice of 3 square. That is 2 into 9 equals to 18. You remember the formula for orbitals. Number of orbitals in any shell, the formula is n square. But the question is about electrons. One orbital has 2 electrons. It means if you have n square orbitals, the electrons will be double of this one. One orbital has 2 electrons. So 2 n square. So answer will be 18 electrons. If there is any confusion, let me know. Formulas, just formulas here, nothing else.
Sir,
Yes.
sir, actually, I also did this from the formula 2n plus 1.
2n plus 1.
Yes, sir.
What do you mean by 2n plus 1?
No, sir, I was just telling that I did it from 2n plus 1 and it's wrong answer.
Right.
One gives us nothing, sir. It is 2L plus 1. No?
The formula is this one. Orbitals n square, number of electrons 2n square. If only shell is asked, then. Next, list the quantum numbers ml and l of electrons for 3D orbital. Read the question again. List the quantum numbers ml and l for electrons of 3D orbital.
You have to do this in the notebook.
Yes, you have to do it in your notebook. And you write it in chat box. I will not tell you the correct answer, but if your answer is correct, I'll say yes, correct. But I'm not going to tell you the correct answer. I'll check your answer, what you sent to me after the class. No, Kazan, again. Okay, Tanu. Ariman, it is ML and L both.
Yes, sir, I sent both.
So write both answers. Amir, read the question again. What is asked? Kavish, your answer is correct. Ariman, yes. Correct. Sanskriti, yes. Give the complete answer. Subway, correct. Arjun, correct. Devyansh, read the question. Lemuel, yes. Arna, give me complete answer, Arna. This is partial but correct. Yes. Goyal, yes. Tanishi, partial answer correct. Pranav, partial answer correct. Okay, quite a few students say that they don't know how to do this. Ahmad, again, you love this number 7. I don't know.
Sir,
So
again
that's
7.
that is your lucky number. The question is list the quantum numbers. Don't tell me the count. List the quantum numbers. You have to tell me the quantum numbers, not the count. Kitej, yes.
Sir, I wrote 7 by mistake. It's loud.
Sir, is my answer correct?
Pratyush, your answer is correct. Pratham, no.
Sir, I had written 7 by mistake, sir. I have changed the answer.
Mhm. Okay, as quite a few students say that they don't understand how to do this question. Okay, I'm telling you here. 3D. 3D means N is 3 and L is 2. List the quantum numbers ML and L. So ML you got from this one and L is 2. D means 2. So you got the value of L 2 and ML will be -2, -1, 0, +1, plus. The answer will be, you have to list ML and L. ML you will list -2, -1, 0, +2, and L 2. That is what you had to write. List the quantum numbers, not the count. List means write the quantum numbers. And by now, I think it is very easy to understand that the values of ML will be from -L to +L. You remember that?
Yes,
After
sir.
that,
Yes.
it is straightforward. Next, which of the following orbitals are possible? You need to write in chat window. Remember, I am asking only for possible. Don't write which are not possible.
So we have to write this one in the notebook as well.
In the chat box. No, not on the notebook. Just write in the chat box. Not possible. Arjun, think again. Not possible. Sorry, possible you have written, correct. Correct. So I am asking for possible, then your answer is correct. Aryaman, correct. Kavish, correct. Subway, yes. Vedant, you have written opposite. Ratnav, yes. Tanishi, yes. No, Samad. No, Kazan. Arna, correct. Fani, yes. Kipik, yes. Amir, yes. Ayush, yes. Quite a few answers I skipped. You can write again. Devyansh, yes. Yash, Goyal, no. Kanu, no. Samad, no. Now you need to understand what are the values. Just consider one. Just consider n. Okay. Here n and l. N is 1. So L can be 0 only, nothing else. Because we know L values will be from 0 to n minus 1. N is 1, n minus 1 will actually be 1 minus 1, that is 0. So 0 to 0 means it will be 0 only. And 0 means it is S. P will not be there. It means this is not possible. First shell will not have p orbital. There will be only s orbital in first shell, no other orbital, no other subshell. Now for n equals to 2, for n equals to 2, L can be 0 and 1. There will be two values, 0 and 1. Means 0 is S, 1 is P. Means 2S is possible and 2P is possible. So these two are possible. In second shell, there will be s orbital. In second shell, there will be p orbital as well, p subshell. But there won't be d. Now come to third shell. Third will have three values of subshell, means three subshells will be there, 0, 1, and 2. Means s, p, d. F will not be there. In third shell, F will not be there, not possible. It means the orbitals which are possible are 2s and 2p only.
I did write 2p, but you said my answer was incorrect.
Come again.
Sir, I did write 2p in my answer. I written 2p and 3f, but you said my answer was incorrect. Then it should be partially correct, I think.
Yes, partially correct.
Sir, excuse me, sir.
Yes.
Sir, can you please show the previous question?
Yes.
Thank you, sir.
Done.
Yes, sir.
Next question. Explain giving reasons which of the following sets of quantum numbers are not possible. So here you need to tell not possible. Now this one is not possible because n cannot be 0. There must be at least one shell. For example, hydrogen. So hydrogen is the first element in periodic table and it has just one shell, one electron. So that is not possible. And you need to write the reason. N cannot be equal to 0. Other things are possible. L can be 0, ML can be 0, but N cannot be 0. Next, this one. Whether possible or not possible. N equals to 1, yes, it can be. Within first shell, there will be only S subshell. So yes, it is possible. Within
Sir, it
this
is
one,
possible.
there
Minus
will
half
be
ds.
only one, yes, only one orbital. S subshell has only one orbital. And that orbital can have one electron having minus half as the spin. Okay. So it is possible. This is possible. Just give me.
So we don't have to write this in the notebook.
No. Just give me a few seconds. Yes, so this one will be possible. Now the next one.
In this question, sir, ML should be 1, no?
In which
Sir,
case?
Sir,
B
P,
part?
sir. Yes, sir, I'm having confusion here for ML.
N, L, ML, MS. N is 1. L can have values 0 to n minus 1. So it will be only one value which will be 0. And if it is 0, it will be from minus L to plus L, means minus 0 to plus 0 means 0 only.
Okay, sir. Okay, sir. Sir, actually, I got confused for the count, sir. I was trying to apply the formula.
And here you can have plus half or minus half. Both are possible.
Yes, sir.
Next one. Now this cannot be possible because for n equals to 1, the possible value of L can be 0 only. For n equal to 1, there will be only one subshell, and that subshell will start from 0, not from 1. So this is not possible. 0 plus half, this is possible. This is not possible because it will be 0 here. Not possible. If there is any confusion, you need to ask. Okay. Next one. For n equals to 2, there can be two possible values of the subshell, 0 and 1, means S and P. So 2 is there, 1 is there, it means it is possible. Within 1, you can have 3 orbitals, -1, 0, +1. So 0 is there. Within 2, 1 is there. Within 1, 0 is there. And this 0 can have +½ and -½ both. So -½ is there. So this is possible configuration. Second shell can have P subshell. One means P subshell. Within P subshell, there will be 3 orbitals. 3 orbitals will be denoted by -1, 0, +1. So 0 will be the 1 orbital. It can have 2 electrons, +½ and -½ So -½ is possible. Next, this one is very easy. We have done this one similar to this one. Tell me the reason whether it is
Sir, in the
possible
chat
or
box,
not. Tell me the
sir, in the
answer in the
chat
chat
box or
box.
on the mic?
Chat box. And why? With reason.
So what is the question?
Question is whether it is possible or not. If possible, then write possible. Yes. If not possible, then you need to give me the reason.
Sir, for E part.
E part, yes. Kavish, yes. Lemuel, yes. Hariman, yes. Sab, yes. Devyansh. Yes, Devyansh. Pratham, no. Vedant, ML can be negative. That is not the reason. Amir, yes, correct. Arjun, yes, correct. Yes, Goyal. Yes, Goyal, what do you mean by quantum number is large? That is not the answer. Samad, no. Tanishi, tell me the reason.
Sir, is my answer correct?
I'm just hoping on the answers. Tanu, yes. Lakshya, yes. Tanishi, yes, correct. Atman, yes. Vedant, yes, now correct. Yes. Vedant, again, yes, correct. Ayush, yes, correct. So if I missed any answer, you can post again.
Excuse me, sir.
Yes.
Sir, there can be two answers for this question, right? Sir, we can
Yes.
say that ML can't be -3.
There can be two, but one is the main answer because I know what you are saying. Okay. You are saying that this is not possible and this is also not possible.
Yes, sir.
That's what you are saying. Okay. However, you say this is not possible because if this is not possible, it is understood that this will not be possible. This is actually written based on this one. If this is 3, only then you can say these values can be -3, -2, -1, 0, +1, +2, +3, right? So this value
Yes.
actually dependent on L. So if L cannot be 3, obviously this will not be possible then. But with this configuration, if you see, if L is correct, suppose, if we don't say L is wrong, then ML is also not wrong.
According to that, N would be not matching.
Right? Yes. So if you don't say L is wrong, ML in this case independently cannot be wrong because it can have value -3 if L is 3. So you have to say L is wrong. Are you getting me what
Okay,
I'm
sir.
saying?
Yes, sir.
If you
Sir,
don't
it
say
is
L is wrong,
dependent on
ML
L,
can.
so if L is wrong, then it will be itself wrong.
Yes. So
Sir, do we
L2,
have to send this question?
no, you don't need to send. So understand these type of questions, very common questions. Okay. So it is advisable that you write both, but this one is primary. Okay. So L cannot be 3 and subsequently, or you can say in turn, ML cannot be -3. Maximum value of L can be 2. For 3, it can be 0, 1, 2, not 3. Now tell me answer of this one, whether yes or no. If no, tell me the reason. If yes, then that's fine. Piyush, Kavish, Laksh, Arman, Samuel, Savya, Arjun, Arna, Pratham, Divyansh, correct. Tanishi, Yash, Koyal, Samad, Naman, correct. Okay, so it is possible. This is straightforward. For third one, you can have 0, 1, 2. Means 2 is possible. Within 2, you can have -2, -1, 0, +1, +2. So within 2, it is possible. And electron can be both +half and -half. Next, give all possible values of L, Ml, and Ms for electrons when n is equal to 3. And if it is 3, you will write it 0, 1, 2. For 0, 1, 2, 0, you will have here 0 only. Okay. Here you will have, in this case, -1, 0, +1. And for 2, you will have -2. So like this, -1, 0, +1, +2. And then corresponding to that, in each you will write +1/2, -1/2.
Yes, sir. I was asking for this part only. Like, do we have to
Yeah.
write it thrice?
Yes.
Do we have to make this table?
Yes. This is the best way to solve such questions. This gives a clear idea to your examiner, to your teacher, what you have done. And otherwise, he will have to or she will have to just search through, which doesn't look good. Yeah. Next question. What is the maximum number of electrons that may be present in all the atomic orbitals with principal quantum number 3 and azimuthal quantum number 2? N equals to 3 means third shell. In third shell, you have azimuthal quantum number L as 2. If L is 2, the orbitals will be -2, -1, 0, +1, +2. These will be orbitals. You know 5 d orbitals were there. L equals to 2 means d. 0, 1, 2, s, p, d. D has 5 orbitals. 5 orbitals will have how many electrons? 2 electrons in each. Total 10 electrons. Only d subshell is being considered here. D subshell of any shell will have 10 electrons. It does not matter whether we are talking about third shell, fourth shell, fifth shell, sixth shell, whatever. Obviously, D will not be present in second and first shells. It will be only 3 and onwards. But if it is there, it will have 10 electrons maximum. Next question. How many electrons in p subshell of argon have same spin? Argon 18 will be 2, 8, 8. So this is n equals to 1, n equals to 2, n equals to 3. So you have n equals to 1, 2, 3. If all shells are completely filled, then you apply the logic that first can have only S. Second shell can have S, P. Third can have S, P, and D. It means P you have here only, P here and P here. In two shells of argon, you have P. Second shell and third shell both have P. One is actually P. This P will have three orbitals. This P will have three orbitals, Px, Py, Pz. These three orbitals will have 6 electrons here, 6 electrons here. Total 6 plus 6, 12 electrons in P subshell. If it is same spin, then you will consider only clockwise or only anti-clockwise. So only clockwise will be 3 plus 3, that is